No. Now I am. All right, so this is second page of the test review guide. So the, for this part, you needed to be able to state which lines can be proved to be parallel from the given statement, and then name the postulate or theorem that justifies your answer. So when we look at number 10, you have to look at angles 1 and angle 5. So angle 1 is here. Angle 5, where is angle 5? Angle 5 is right here. So if those two are congruent, if their angles are the same, then what two lines are your parallel lines? And what is your transversal?
So A and B and D is your transversal.
There you go. I know, I'm so obnoxious. A and B is what we just proved to be parallel, because if line 1 and line 5 are congruent, then that means A and B have the exact same slope. They're perfectly parallel. What postulate tells you that, Andrew? Okay, no, okay, what are angle 1 and 5 to each other?
They are congruent.
They are congruent.
Because they're.
But what about their like relationship to each other? Are they both on the same side of the transversal?
Yes.
So they're either corresponding or correlating. They're corresponding. So this is the
Corresponding angle postulate.
yes. Corresponding. I'm sorry, you'll have to use symbols. I tried to make them as long as I could, but because of the image, I couldn't make them all fit. Corresponding angle postulate. The only postulate we have. All right. Stop smacking gum, please. Okay, number 11, we are now comparing 10 and 15. So we have angle 10 here, and we have angle 15 here. So, Chad, what lines do these prove as parallel? Okay, yep, still A and B. Very good. Alternate exterior, alt, EXT, angle, theorem. I can't rest my palm on this, so my handwriting is going to be even worse than usual. But yes, the alternate exterior. So they're both on the outside of the parallel lines. So they're exterior, and one is on one side of the transversal, one is on the other. So they're alternating. Okay. And what about number 12? We're looking at angle 7 and angle 15. So 15 is congruent to 7. Which lines are parallel? So this one is proving that line C is parallel to line D. And what are we using to prove that? Yep, same as number 10, corresponding angle postulate. So
What's the difference between corresponding and?
So the consecutive interior angles are supplementary. Yeah. So if you look at the consecutive interior angle theorem, then that tells you that angle 3 and angle 4, or excuse me, like angle 3 and angle 5, they are both interior of the two parallel lines against the transversal. They're on the same side. So they're correlating. They're not the same. So they don't correspond to each other, but they do correlate and equal 180. So there's still a relationship between the two. Yes. Okay, so number 13, Gabe, you have this one. Angle 4 and angle 9. So we have angle 4 here and we have angle 9 here. What two lines, if we say these two angles are congruent, what two lines are then parallel? Are A and C parallel? Parallel.
Yeah.
And yes. Okay, so this one again proves that line C and line D are parallel. Those are not L's between my A and my B and my C and my D. Those are the symbol for parallelism. All right, so what theory or postulate proves that? What are angle 9 and angle 4? Are they on the same side of your transversal or opposite sides? Right, so they're alternating. Are they inside the parallel lines or outside the parallel lines? They're in between C and D. See that? So they're inside. So what do we call that? Interior. Yeah, so this is alternating interior postulate. Well, sorry. Angle theorem, yes.
Oh, what the heck?
I'm sorry. Corresponding is the only postulate. Just having a moment. Alternate interior angle theorem is what that is. All right. All right, Abigail, number 14, 6 and 13. If I tell you that angle 6 and angle 13 are supplementary, what two lines does that prove is parallel? Yep, still C and D. So C is parallel to D. And what postulate or theorem is proving that? Are they on the same side or opposite sides of the transversal? Same side. Are they on the same side of the parallel lines or on the opposite sides of parallel lines? They're on opposite sides. So they're both interior. It's like not the corresponding, it's the consecutive. Right. So consecutive interior angle theorem.
If they're consecutive, they're supplementary.
Yes. Right, so consecutive interior angles means they're inside the two parallel lines that they've proved, and they are going to be supplementary. All right, let's do some proofs.
Yeah.
Like, yay, not. No, it'll be fine. Hold on, let me pause this. Let me make sure. Did you pause? Thank you. Okay. The nice thing about these is that they're fairly short. The ones you're going to have on your test are also fairly short. And what always is the first statement of your proof, Aiden? You're given. So what is always the last statement of your proof? What you're trying to prove. The question is, what are your reasons? Now, the reason for your first one is given. Now, so this is the part you got to get your brain around. This is the whole logic chapter we had, chapter 2. So you have to look at what you're given and figure out how you use that to get to your end statement, what you're proving. Now, they already give you angle 3 in your given, and they tell you that D and C are parallel. Now, in your proof, you also have angle 3, so we don't have to convert angle 3 to anything, but we do have to convert angle 6 to an angle 15. So first off, let's go ahead and mark angle 3 is congruent to angle 6, and we know that D and C are parallel. No. Umbrella. Ella. Okay. Yep. All right. So how do we get from angle 6 to angle 15? Okay. Can he have it? He doesn't get nearly as many moments. Okay.
Alternate interior angle theorem.
The alternate, so what do I put on my statement? Okay, so Aiden, what do I need to put on my statement side? You gave me my reason. Angle 6 is congruent to angle 15 because, as Chad has told us, the alternate interior angle theorem tells us so. All right. So Caleb. Well, okay, I can give it to anybody, but I'm like back to you. I've gone through everybody else in the class. Can you tell me how we get from angle 6 is congruent to angle 15 and angle 3 is congruent to angle 15.
Substitution.
What property did we use there?
Substitute.
There's something else.
He really bit. You bit. Baked.
Let's see. Oh, no, it's okay. Look, yeah, everybody does. Everybody. What do we call the property that says if A equals B and B equals C, then A equals C? Remember what we call that? If A equals B, we've been learning this, y'all, I've been teaching this and I taught this in pre-algebra last year, and then we've done it in algebra. Not quite. Associative means you can change the order that you add or multiply things in. I can try. There's a wall there, so it makes it a bit difficult. You can always just move over here. I know that angle is a little bit rough. I can't move the TV anymore. There's the symmetrical property of equality. Starts with a T. Transitive, right? Now, what are being transitive here? What are we working with? We have the transitive property of line segments. We have the transitive property of parallel lines. We have the transitive property of equality. And we have the transitive property of congruent angles. Yes, okay, transitive property. Are you using a pen? Then you'll be fine. Of congruent angles. I remember on the test I saw the transitive property being used as a reason multiple times. So that's a big one. That's so easy though, because all you do is prove that this equals this. And then because of a relationship, that also equals this, which means that the one you started with also equals the one that you ended with, and it works. Okay, these next ones are very important, and I added them on because you will be using them in practice. I am giving them to you in theory. And then you need to use them to determine things on the test. I'm sorry, that doesn't really make much sense, but I think it will once you see the test. Okay, what is the difference between the corresponding angle postulate and the converse of the correspondent angle postulate that I accidentally wrote as a theorem? Sorry. Would you like for me to read it? Aiden.
You use the corresponding postulate to find that angles converse.
There you go. That is a vital distinction. And y'all, this is important with all of these. You have a converse to the corresponding angle postulate, the alternate exterior angle theorem, the alternate interior angle theorem. You have converses to these. So the corresponding, I can't even. Oh my goodness. I can't do it without resting my hand on it. Let me just write it. I probably need them. Gamer gloves. Do I need gamer gloves? Like fingerless?
No.
Okay. The corresponding angle postulate, you're going to want to write this down, uses parallel, lines. I am still recording, right? Yeah, okay. Uses parallel lines to prove congruent angles. The converse uses congruent angles to prove parallel lines. Did I not give you enough room?
I'll just like. hold it.
I know you are. I deliberately made sure that I gave enough lines, or I hoped that I gave enough lines
You
with
did.
you in
It
mind.
worked.
Okay,
I
good.
just symbolized.
It's all right. It's a thing.
You write that.
Well, it's a sign of genius. It's
Who
okay.
says that? That's actually.
People whose brains work faster than their fingers. That's why. But don't bark at it because now you just proved me wrong. All right. Barking like a seal in the middle of my classroom.
My fingers and brain.
Whoa,
work at the
no,
same
no.
time.
All right, sorry. There you go. But do y'all understand the concept I'm talking about? If, yes, you do. You're the one who explained it to us. Stop messing with me. Of course I'm recording.
Can't wait to go back on
The
that.
videos from this week and last week have been fairly entertaining.
No, there was one that was really. It's the one where I was jump scaring Abigail. That one's really bad.
Oh, I got a video of you trying to jump scare Abigail.
Yes.
Poor thing. Poor Abigail. Oh, I did write this down. Good.
And you said, and I quote, "Stop jump scaring her."
All right.
At least it's not for now.
Yeah.
Make sure you guys subscribe to the JCA Sleep Club.
All right. So that's the first one. What is that on y'all's? Is that- Okay, it is in the middle. I have two different copies. Okay. All right, moving on. State the transitive property of parallel lines. Now, we just used the transitive property of congruent angles. So if does anybody have their note cards and would write? You got it? Okay, tell me the transitive property of parallel lines.
If two lines are parallel to the same line, then they are parallel to each other.
Good job. Okay. So if two lines are parallel to the same line, what do we call this same line? The transversal.
Well, you gave a bunch of space for this one.
Well, you know, oh yeah, I kind of did, didn't I?
For the long answers, he'll give one line. For the
The
short
short
versions,
versions
he'll
would
give
be
you
like a whole paragraph.
For the short versions, he'll give you like 4 lines. For the long versions, he'll give you 1 line.
There's a lot of copy and pasting or cutting and pasting that goes on in my review guides. That's why you'll have like if you'll notice on page 1, you have a section 1, Roman numeral 1. You have 2 Roman numeral, oh no, maybe I fixed that.
You know, there's 2 Roman numeral 2s.
Yes,
And
okay,
you-
I fixed it on my copy, but I did not fix it.
You went on to explain it in
Yeah.
the video, and neither Chad nor Caleb knew what you were talking about, and it's really funny.
Okay. But yeah, okay, so the transitive property of parallel lines is what I just wrote. And I don't know, oh, yeah, I do know why. All right, and so that's the number 16 on page 2. No, yeah.
Yeah.
Number 17,
Another term.
what is another term? Did I spell it wrong?
No, it's
Thank you, because that definitely happens. Oh, messing with me. And I'm falling for it. That's the worst part. I'm usually a lot better than that. What is another term for slope?
Rise, run, overrun, rise, overrun.
And what do we call the right over? What do we call a rise over run? No, I'm not asking for an equation.
We call it in?
We call it the rate of change. So rate of change is all that goes on there.
It's the ratio. There's something in math called the ratio, isn't there?
Yes. And that is not a rate of change. So
That's
don't
what I
confuse
was
that.
thinking slope was ratio. I'm tired.
Yeah, no, slope is definitely not a rate. Well, yeah, I mean, it
It
is.
can be.
It's a ratio
Yeah.
of rise to run.
Yeah.
Absolutely. But rate of change. So and right now, because we're in basic geometry, we work with a constant rate of change, but it can be positive or it can be negative, right? Positive means it's getting bigger over time or over whatever your X is, and negative means it's getting smaller. So positive, I put that here, so, or negative. All right, number 18. I gotta keep myself on track. Okay. Oh, that's right. So for section, see, I have 2 section 5, 6s, don't I?
I can't read it. Yes, you.
Yes.
Yeah, see, I did that too. Okay, so for this next one, use the X and Y intercepts to graph each linear equation. So this is the part where I change this back to
It's
graphing.
gonna mess up and you're gonna get mad and I'm scared.
It'll be fine. I'll try to stay chill. Okay, so for number 18, we have, so, okay, there we go. We have, what, X plus Y equals 2. All right, so give me this in true linear equation form. Slope-intercept form. What do I do?
M equals. No, Y equals.
Y equals.
Y.
No, turn, yeah. Okay, we'll write it over here. Here's our generic one. Y equals what? What, Andrew?
X plus B.
All right, so is that what we have currently? In blue? No, we do
have to
not.
make it happen.
Yeah, you gotta make it
You have to
happen.
Subtract 1x from both sides.
Right, so minus X. So Y equals what?
Negative X.
Plus.
Yes, we're adding these,
Plus ratio.
right? So what's my slope? -1. What is the coefficient to my X? You know where I got that from? You with me? Remember, slope. And what is right there? What is your understood coefficient if you have none showing with a variable? It is 1. So if you have a negative, that is like X times -1. So your slope is -1. What is your y-intercept? +2. All right. So now we just graph it. Easy peasy. Where do we start? What, you've got that?
No, wait.
Oh my goodness, okay.
No, I'll just look off after.
Okay, that works.
Hmm?
Let me get to the right place here. Okay, so we have our equation y equals -x plus 2. So where do I start? Gabe, do you know? I'm making a line. Where do I start?
Zero.
You start at 0 and then you have to find what? Your y-intercept. What's my y-intercept? I'll get to you in a second, Chad. What's my y-intercept? It's 2. All right, so that means what? With my graphing my line. What is the y-intercept? That's where the line does what? Intersects line or your y-intercept, while your y-axis. So where does the line intersect my y-axis? Right here? Okay, great. Yes. You've got to do that first. That gives you 1 point because what are the coordinates of that point? Thank you. 0, 2. Okay, so Caleb, what do I do with my slope? I need another point so I can draw a line. So which direction over? If I go up 1, because what's my slope?
So you would have to go left 1 and down 1.
What is my slope?
Negative.
Negative. So let's do -1/1. Because that's 1, right? All right, so that means what? If I go up 1, do I go left or right? That's +1/1. Right, so you have to make sure you recognize with your slope, if it is negative, first off, your line needs to be going downhill when you're done drawing it. If your slope is negative and your line is going up As you move to the right, you've done something backwards. So slope is either -1/1 or it is 1/-1, right? Because both of those are -1. So you can pick one or the other, but you cannot mix because a negative over a negative is a
Positive.
exactly. Okay, so if I go up 1, then I got to go left 1. That means if I go, so Chad, if I go down 1, I got to go right. So did we, oh, golly, I didn't even try. Stop.
I have this thing called
A ruler,
but it's curved and it's like half a circle.
but one side should be straight. Yeah, you got a straight side.
Yeah, what's it called?
Oh,
Not a rule.
the compass?
Protractor.
Is it the so the compass is the,
No,
why am I forgetting?
that's the compass.
I thought you were talking about the flex.
I also thought he was talking about a flex ruler.
All right, so I will accept this if your points are accurate. Don't worry about having a perfect line, because obviously I know how it goes. Now, does it look right?
Look at that. That looks beautiful.
See, that looks much better than mine, that's for darn sure. All right, so first stop. Why? My 7th graders did that today. Nobody's ever done that. Now 2 classes total have done it today.
I do it all
All right, so first off, you have to write your equation on the line here. Y equals -x plus 2, and then you have to graph it, which we've done, so we're good. Everybody got this?
Yeah.
Good, okay.
Plus 2.
Mm-hmm.
And mine is
I would
3.
hopefully have the work that I just did that shows you how I got that to be -x plus 2. Okay, good. Okay, so I have 5x minus 3y equals 15. You want this one, Andrew? Okay, you solve it and then I'm gonna have Abigail graph it. All right, okay, so,
So y equals mx plus b. So
right,
to get that, you need to get 5x on the other side, which means you subtract 5x from both sides.
right,
Okay, which leaves you with -3y. Ready for this? Equals -5x plus 15.
you're right. No, you're right, you're good. All right,
Now,
now,
you have to get the y alone,
yes.
shall we say? Meaning you divide both sides by -3.
This is a very careful step. Please make sure you divide all parts by -3. A lot of people will try to just put a whole line under the -5x plus 15 and divide it by -3, which is fine as long as you remember that you can then separate that -3 into the 2 parts of that algebraic expression.
We have y equals -5x over 3, -3.
Which simplifies to what?
I don't know.
What's a negative divided by a negative?
Sorry, 5 over 3.
5 over 3.
I think you're asking me for the decimal.
And then you can always just pull the x out and put it next. We're just saying 5/3 times x
Yeah.
is the same thing as 5x over 3.
Plus-
Do we all see that?
Yes.
Okay,
Plus -5.
well, which
Well,
is,
-5.
there we go, which is -5. But good job, because we know that adding a negative number is the definition of subtraction. I got one better for you. All right, now that gives me my equation. That's it. That's what you're getting. That's the whole point. Thank goodness. I will never, ever have that recorded. My Momo face.
My phone was.
Yeah, funny. All right. If that's the case, then go and turn that in. I'll send it up to the office. When I know
You
it's
want
up.
the video?
No, the phone.
Oh, I have to be sharing video.
Okay, so we have our equation. So Abigail, what on earth do we do with this equation now? So tell me my parts. What does this 5/3 stand for? That's your slope. What about this -5? That's your y-intercept. So where do we start? Absolutely. Where is it compared to my origin? 5 down from the origin. Yes. So 1, 2, 3, 4, 5. right here. I'm gonna get rid of that now. All right, so we now have 1 point. What's the coordinate? Of course, you don't necessarily have to do this right now, but if you're having to calculate something, you can. Just know the coordinate for your y-intercept is always going to be 0 for x, and then whatever your y-intercept is. Now, how does the slope help us determine where the line goes from here? Right, what is the 5? Okay, in 5/3, what does the 5 stand for? That's your rise. And remember, rise is like up and down, like we rise up, right? So that's your y's. And then run, you run across a straight field. You can't run like, that's your y's. So this is your run. So if you can remember that rise means you go up or down on your, right. So it's, no, rise is y and run is x. Okay, so now here's the thing. Remember, we can make two different points from our y-intercept. Now, 5/3 can be a +5 over a +3, but what is another way to express 5/3? Because what's a negative divided by a negative? It's still positive. Thank you. So that helps you find that third point. You don't need 3, as long as you've got 2, you can draw a line from it. But if we started our y-intercept of -5 and we have our rise over run, I need to go, what direction do I go 5 points? If we use, let's use this one. It's still Abigail's.
Really stealing it. We go from.
Right. So it puts us back at 0, right? And then what is my run? Which means I go where? Left or right? Right, 3, right? So I go up 1, 2, 3, 4, 5, right back where I was, and then over 3. And so I have my first coordinate right here.
Vertex. That's what it's called.
What, the vertex?
Vertex. I've been questioning myself for the past 30 minutes.
Where did vertex come from?
It's the middle, the 0, 0 is called the vertex.
It's called the origin.
Bozo.
No, so the vertex is the point of the triangle. The vertex is the point where the 2 lines meet. Yeah, and the angle is the actual measurement. It's okay, I'm sorry. But I'm glad you had that moment.
Yeah,
I'm sorry I had to ruin it.
no, it's fine.
All right, so what if it's -5 over -3? So that means I go down 5, 1, 2, 3, 4, 5. Left 3. And I have 1, 2, 3 of this guy right here. And so you can see they are perfect opposites, perfect mirrored opposites from the y-intercept. And so you have your line, something like that. So now you have graphed it. And you didn't need that second one to do it. You could have gone from your y-intercept to that second point that is 3, 0 and still, but check it and make sure, like your slope is 5/3, it's a +5/3. Is this line going uphill as it moves to the right? Yes, so you know you've got a positive slope. So if it matches what you calculated as a positive slope, you're good to go.
You know when you have like.
Once you've practiced it enough,
You
yeah.
have like a pimple forming, but it's not.
And it
there
hurts
yet,
really
it just
bad,
hurts really bad.
Especially if it's in like the crease.
Yeah.
These are the worst.
That side.
Or like in your lip. Yep, those are awful. All right, Chad, this one's yours and then we'll go. Well, he's gonna do my equation and you're gonna graph it. I think I've got everybody else. All right, so you keep chiming in for everybody else's. So I don't have a chance to call on you,
Okay, so the objective here is to subtract 4x from both sides.
right?
So that gives us 2y equals 12 minus 4x. But we can't have that, so we have 2y equals -4x plus 12.
There we go.
Okay. We have to divide out 2 out of y.
Mhm.
Everything by 2. And that gives us y equals -2x plus 6.
All right.
Okay.
So y equals -2x plus 6. So Caleb, what do we do with it? Where do we start?
I did it a different way, so now I'm confused.
You did it a different way. Did you get the same answer?
Well, I got y equals 2/1 times x plus 6.
Right, and 2/1 or -2/1?
2/1.
Okay, yeah, you missed a negative somewhere. Because -4, okay, so you didn't have your 4x as negative. So you got to subtract it. And then you can have a -2x/1, but as long as you recognize that any number over 1 is itself. So then you're just left with the -2x. No matter what x is, if 1 is the denominator, you just eliminate it.
Yeah.
Anyway.
Right. So once you get that straightened out, so where do we start?
6, you go up 6.
Stop. Ah.
I'm sorry.
All right, Chad, Caleb Jr. I know, right? That would be awful. It's like in my house. Every time I yell at the child, I call the dog's name first. Yeah, well, I only had the 2 of them for too long. Okay, sorry. Let's go ahead. We're almost done here. Please, let's be done.
So what would you have? You would have -2/1 or
Right.
2/-.
Because you're gonna want that. Yeah, you are gonna want that when you go find your rise over run. So you went up, you said you went up 6.
Yeah.
1, 2, 3, 4, 5, 6. So here's my y-intercept.
You go down 2 until
Okay, so we can go down 2.
you're right.
So down 2 into the right one. Or we can go up 2, but we have to go to the left one. All right. And so now we have our slope. That is correct. All right, that's it. We'll finish more of this tomorrow.